Hello students, good morning. Welcome to my lecture on chapter number 10 Halogen derivative. In the previous lectures we have studied about nucleophilic substitution reactions of haloarenes. Haloarenes are also called as aryl halides. Now today we are going to study mechanism for the nucleophilic substitution reactions of haloarenes. Now see this example. When para-nitrochlorobenze reacts with alkali at 433 Kelvin, then para-nitrophenol is formed. This is the example of nucleophilic substitution reactions. Now, we are going to study the mechanism of that reaction. Now see, it is para-nitrochlorobenze. Here intermediate form is what? Now you remember intermediate. Which intermediate is formed in this reaction? Intermediate is carbon ion. Now we are going to write down resonating structure for that reaction. Before that, you know that OH is what? Nucleophile. Now see this NO2. How to write down? Nitrogen contains 5 valence electrons, 1, 2, 3, 4, 5. Here oxygen acquires negative charge because oxygen do not share any electron in the formation of this single bond. But here see, oxygen, the valence electrons present in the oxygen are 6. See 1, 2, 3, 4, 5, 6. Now this is the structure of what? Para-nitrochlorobenze. Here nitrogen shares 2 electrons, 1, 2, 3, 4, 5 to this oxygen. Therefore, here nitrogen acquires positive charge. Now see, nucleophile. It is electron rich. It attacks this carbon atom. So you get what? This bond is formed because of these 2 electrons. Now we have to write down the resonating structures. In resonating structures, we have to change the position of pi bond. 1, 2, 3. See the position. Observe this and observe this. There is a change in the position of pi bond, or we can say delocalization of electrons. Delocalization of pi electrons. Now see, all these things are very simple to understand because you know that how to write down resonating structures. Now see, here these electrons, see this arrow. So here you get what? Negative charge. There is no change in this structure. Now see this next step. See this arrow and this arrow. What will you get? There is a formation of double bond, and because of this arrow, here you get what? Negative charge, because here electron density is more, and this is what? Para position. This is ortho position. Means see, at ortho position electron density is more, and at para position, see, this is what? Para position. This para position where electron density is more. Now let me wrap this to avoid confusion. See, it is ortho, it is para. Now see these arrows. Now what happens in the third resonating structures? Because of this arrow, there is a formation of double bond, and because of this arrow, again oxygen gives 2 electrons and acquires negative charge. So this is third resonating structures. Now see the difference between first, second and third resonating structures. In third resonating structures, at para position, the conjugation is extended. Conjugation means single and double bonds, they are alternate. Single, double, single, double, single, double. Now see the fourth resonating structures. What happens here? Again, there is a formation. See these arrows. See these arrows. Because of this arrow, there is a formation of bond. Now, because of this arrow, again there is a formation of bond. Negative charge is removed. See, this is fourth resonating structures. Now, and see this arrow. Because of this arrow, there is a negative charge. Now, for the fourth, see this arrow. This forms this bond. Again, these electrons shifted to chlorine. Therefore, this bond is break, and that place is taken by only OH. And there is a removal of chloride ion. Now see, this is the formation of para-nitrophenol. I hope you understood this. Let's start with electrophilic. substitution reactions. Electrophilic substitution, it is written as what? Se of aryl halides. First of all, if you write 6 electrons, electrophilic substitution of aryl halide, it is shown by Se. S for substitution, E for electrophile. Now before going to study this, you must know the resonating structures of chlorobenzene. Now see, chlorine contains 7 valence electrons, 1, 2, 3, 4, 5, 6 and this 1. But chlorine have capacity to share these 2 electrons and therefore we get resonating structures. What happens here? Here there is a formation of chlorine having positive charge because it loses 2 electrons. Here you get negative charge. Now see the next. This auto position. What happens again here? 1, 2. Positive charge. Here negative charge. See again next. Chlorine, positive charge. What happens here? This bond will form. Here you get what? Negative charge. Again see. This goes here and this goes again here. So you get again chlorine. Here you get bond. This one, this one. Now see. These are the resonating structures of chlorobenzene. Now see. At ortho position, see it is ortho position and it is para position and it is meta position. Remember that. You know that this 1, 2, 3, 4, 5, 6. These are ortho position, these are meta position and this is para position. Remember that at ortho position and at para position there is more electron density and therefore these electrophile can be shown by this way. Electrophile, they are what? Electron deficient. So they can attack at ortho position or they can attack at what? Para position. But they are not able to attack at meta position because meta position there is no electron density. I hope you understood this concept. Let us start with the main reactions of chlorobenzene. I hope you understood this. Halogenation. Now see, this is chlorobenzene plus what? Cl2 develop FeCl3 as a Lewis acid. First of all, Lewis acid, they are what? Electrophiles. So this FeCl3 is used to generate electrophile. It helps in the generation of electrophile. So this will happen. Here you get for Cl plus FeCl4 minus. So this acts as what? Electrophile, and electrophile act as ortho position and para position. So what is the product? Chlorine. Here you get what? Chlorine plus chlorine and chlorine. Its name is what? Para-dichlorobenzene. Para-dichlorobenzene, and it is ortho-dichlorobenzene. Ortho-dichlorobenzene. Now, which is the major and which is the minor? See here. There is a repulsion between these two chlorine groups because both are what? Negatively charged, and therefore it is what? Major, and it is minor. Here repulsion takes place. See here, this is symmetrical. This is symmetrical. These are not symmetrical, and that happens. And therefore, para-dichlorobenzene is what? Major, and ortho-dichlorobenzene is what? Minor. Plus, you get what? 2HCl. It is what? Chlorobenzene. Now see the second reaction. That is what? Nitration. Take 2 molecules chlorine, 2 molecules of this reaction is carried out in presence of what? Concentrated sulfuric acid. It is required. Now see, concentrated nitric acid. Concentrated sulfuric acid helps in the generation of electrophile, that is nitronium ion, that we will see. The structure of sulfuric acid: HOSOOH. Now what happens here? 1, 2, 3, 4. Now there is a removal of proton. So what will we get? HOSOO 1, 2, 3, 4, 5, 6. So it requires negative charge plus what? H plus. H. You get O double bond N double bond O H. These two electrons are responsible for the formation of this OH bond, and therefore oxygen acquires positive charge. And here again what happens? This is unstable, so you get O double bond N double bond O NO2 plus what? OH H2. It is what? Nitronium. Now see, it is sulfuric acid. It is nitric acid. H2SO4. Now first there is a formation of proton. This proton acts as what? Electrophile. And remember, always remember, electron goes towards electrophile. Electron goes towards electrophile. So this type of error. So what happens? There is a formation of this OH bond. Again what happens? It is unstable, and therefore this bond breaks to form nitronium ion. So sulfuric acid helps in the formation of this NO2 group, that is nitronium ion, which act as what? Electrophile. So electrophile can attack it or can collaboration. See this properly. We'll proceed for next step. So you get here you get chlorine, here you get what? NO2 plus chlorine NO. This is 1 4 nitrochlorobenze or ortho-nitrochlorobenze plus 2H2O, because one hydrogen atom is lost from this position and one hydrogen atom lost from this position, and there are two OH groups, so you get what, 2 molecules of water. Now see the next reaction, that is sulfonation. Sulfuric acid can be written as HOSO3H with 2 molecules. Here 2 molecules. Heat. What happens here? HOSOOH. First slow step, you get what? HOSOSO 1 2 3 4 5 6. There you get what? Minus charge plus what? H plus. Now see the second step. HOSOOH plus what? H plus. So there is a formation of HOSOSOH positive charge H. Again there is a formation of, there is a breaking of this bond, so you get HOS double bond O having plus charge plus OH. So this is sulfonic acid. Sulfonic acid. Sulfonic acid acts as what? Electrophilic. Acts as what? Electrophilic. Now see, first of all, there is a breaking of OH bond, then you form these two ions. This proton again attacked by this sulfuric acid to form these structures. Then there is a formation of what? SO3H. That is what? Sulfonic acid. And this sulfonic acid acts as what? Electrophilic. It can attack a ortho and para position. SO3H. This is written as what? SO3H plus SO3H plus 2 molecules of H2. That we understood. This is called as what? Benzene sulfonic acid. And it is ortho-chlorobenzene sulfonic acid. Sulfonic acid. It is minor and it is major. Always remember para products always dominates ortho products, and therefore para products are what? Major. Reactions, Friedel-Crafts reactions. There are two types: Friedel-Crafts alkylation. Here it involves introduction of alkyl group, that is methyl group. Now, and second one is what Friedel-Crafts acylation. Here it involves introduction of this acyl group. That is, here it is acyl. See here COCH2 is what acyl group. Now come to Friedel-Crafts alkylation. What happens here? Methyl group attack at para position, and here methyl group attack at ortho position. Therefore, you get what para-chlorotoluene. It is what major. You remember always para product are major and ortho product are what minor. So here you get what 2Cl. Two hydrogen atoms are lost, and therefore you get what 2HCl. Now see again here, same thing is happened. COCH2 attack at ortho para position and COCH2 attack at ortho position. Therefore here you get what para-chloroacetophenone. It is major and ortho-chloroacetophenone is minor. So these are the Friedel-Crafts reaction, and already we have studied about this in 11th standard in benzene. Yes, already we have studied about this. It is para-chlorotoluene because if you hide this chlorine, it is what toluene. So it may be para-chloroacetolene. It is ortho-chlorotoluene. It is ortho position. It is para position. See 1, 2, 3, 4. 1, 2. 2 means what? Ortho. Similarly with the Friedel-Crafts acylation. So I hope you understood this concept of Friedel-Crafts reaction, and now for this year this chapter is completed. All the best. Enjoy the study. Thank you very much.